be going over Module 1 review, expressions and equations. I will be going over all the sections from Module 1. You can fast forward to the section that you need extra help with. 1.01, we're dealing with expressions. With expressions, we want to tell what type of operation is going on here. This first one is the difference of two products. Difference means subtract. Product means multiplication. We have 3 times A, that's a product. 5 times B, that's a product. So the difference of those two products. The next one, we have 4M plus 7N. That is the sum of two products. 4 times M plus 7 times N. Sum means addition. The next one, we have 2 times C plus 8. That would be the product of a number and the sum. So with this problem here, it's a little different. This 2 is being multiplied by this entire sum. So that's why we have the product of a number and the sum. 1.02, we're dealing with equations. Here we have an example. Charlene solved the equation negative 2x plus 14 equal negative 4 times x minus 5, but she made an error. So these are all the steps that Charlene completed. And so within her steps, she made a mistake. In order to find that mistake, it would help you to go through the steps one by one. So the first step would be to distribute that negative 4 on the right. So when we do that, we get negative 2x plus 14 equal negative 4x plus 20. Everything is the same. So this step is correct. The next step, we want to get our x's together on one side. So I can see that Charlene put her x on the left side. So that means she moved this negative 4x over with the negative 2x. That's a negative 4, so we have to add it. So when we add it, we get negative 2 plus 4, we get a positive 2. So we can see right here, this is the mistake. So now that we found the mistake, we want to go ahead and correct everything. So we have 2x plus 14 equal 20. Now we want to move that 14 over to the other side. It's plus, so we're going to subtract. So then we get 2x equals 6, divide 2, x equal 3. So whenever you're given a problem like this, where it gives you all of the steps, you kind of want to do it on your own to check to make sure which step, because sometimes just looking at it, when you look at it, sometimes you don't see the error. But when you actually work it out and don't look at the steps, then you can figure it out on your own. The next problem, we have a fraction in our equation. 1 over 6 times x plus 5 equal 2. Now, like most students, I know that we don't like to deal with fractions too much. So with a problem like this, we can get rid of that fraction and we don't have to deal with that fraction at all when we solve. We may still get a fraction answer, but we don't have to deal with that fraction. Now, with this problem here, we have 1 over 6 times x plus 5 equal 2. I can get rid of this fraction by multiplying the denominator. We have one fraction, which is 1 over 6, so I can just multiply the denominator. If I multiply the denominator by everything, that will get rid of the fraction. So our denominator is 6. So when we multiply both sides by 6, what's going to happen is this 6 and this 6 cancel out. So they cancel out here, and we multiply it on the other side as well. Because remember, whatever we do to one side of the equation, we have to do to the other side of the equation. And so when 6 times 1 over 6 cancels out, we're left with only x plus 5 on the left side. So we have x plus 5 equal to 12. Now subtract 5, x equals 7. So you can always get rid of the fraction by multiplying that denominator. Whatever the numerator is, that may still be left, but in this case, our numerator was just the number 1. So 1 times x plus 5 is just x plus 5. 1.03, inequalities. We have an inequality problem that needs to be worked out. Glenda was given the problem -4 times 3x minus 6 less than or equal to -3 times 5x minus 4. These are all of Glenda's steps, but she made a mistake. So we want to do the same thing that we did for that equation where there was an error that Charlene had made. So we're going to, first thing we're going to do is distribute that -3 on the left and that -4 on the left and that -3 on the right. So when we do that, we get -12x plus 24, -15x plus 12. Keep in mind that a negative times a negative give us a positive. A negative times a negative give us a positive. So this first step, she did correctly. The next step, Glenda needs to move that 15 over to the left side. So when she moved that 15 over, it's a -15, so she has to add it. So since she has to add it, -12 plus 15 give us a positive 3x. And we can see here this was the mistake because she kept it as a -3. So now the mistake was that sign. Those signs, you need to pay attention to them carefully because if you make one error with the sign, it can mess up your entire problem. So next we move that 24 over, it's added, so we subtract. We get 3x less than -12, and then x is less than or equal to -4. So you can see here that with the original answer that Glenda had, let's say that this was a -3 when she worked it out. Let's say that was supposed to be -3. When she worked it out at the end, notice that when she divided this -3 here, this less than became a greater than. That's because the rule is whenever you multiply or divide a negative with the inequality, that less than becomes greater and that greater becomes less. But in the answer that, the correct answer, there was no negative in front of our x. Since there was no negative in front of our x, we divided a positive number. So we did not need to flip the inequality. It stays as less than. Okay, still dealing with 1.03. This is what we call a compound inequality. Here we have 2x minus 3 in the middle. We have three sides to this inequality. We have -1, 2x minus 3 in the middle, and then 11 to the right. Whatever we do in the middle, we're going to do to the left and to the right. So the first thing we need to do is move this 3 over. It's subtracted, so we're going to add it. So we're going to add it to all three sides. So here we add 3. -1 plus 3 is 2. When you add 3, the 3's cancel. 11 plus 3 is 14. Now we have 2x. 2 is multiplied by x, so we're going to divide 2 by everything. So when we divide 2, 2 divided by 2 is 1. 2x divided by 2 is x. 14 divided by 2 is 7. So we get 1 less than x less than 7. 1.04, we want to add and subtract polynomials. Okay, this example that we have is -6y squared plus 3y minus 4. Subtract 9y squared minus 3y plus 7. We want to subtract these two polynomials. Normally, when we have addition, we just combine the like terms. We take the y squareds, put them together, the y's, put them together, and the numbers, put them together. But this problem has a subtraction. When there's a subtraction, you need to distribute this subtraction to every sign in the parentheses that's after the subtraction. We don't do anything to the first one. It stays as it is. But whatever polynomial is after the minus sign, you're going to distribute that negative. So we're going to distribute this negative, and we're going to use the rules for addition. So this positive 9 becomes negative. This minus 3 becomes plus. This plus 7 becomes minus. So every single sign changes. Now we can use the rules for addition, combining the like terms. The 2y squareds, the 2y's, and then the two numbers. So the negative 6y squared minus 9y squared plus 3y minus 4 minus 7. So negative 6 minus 9 is negative 15y squared. 3 plus 3 is positive 6y. Negative 4 minus 7 is negative 11. Now, like I had said, had this been just an addition problem, we would have went straight here and just combined the like terms. But whenever there's a minus here, you distribute that negative sign and change to addition. And you use the rules for addition. Now let's move on to 1.5, multiplying monomials. Here we have negative 7a to the third, b to the third, times 7a to the fifth, b to the first. We want to multiply these two monomials. Whenever we multiply the monomials, we want to multiply the numbers, and we want to multiply the variables that have the same letter. So we're going to multiply the negative 7 and the 7, the a to the third and a to the fifth, and the b to the third and b to the first. So negative 7 times 7 is negative 49. Then we have a to the third, a to the fifth, times b to the third, b to the first. Now the rule is whenever you multiply variables, you add those powers. Whenever you multiply variables, you add the powers. So if you get confused with that, because some students do, let's take a look at a to the third times a to the fifth. A to the third is 3a's. A to the fifth is 5a's. When you count that, you get a total of 1, 2, 3, 4, 5, 6, 7, 8 A's. So that's a to the eighth power. So whenever you multiply variables, you add the powers. Let me make that a little bit bigger here so that you can see it a little better. Okay, so that's bigger. So 1, 2, 3, 4, 5, 6, 7, 8 A's. So a to the eighth power. So whenever you multiply variables, add the powers. So we get negative 49, a to the eighth, b to the fourth. Remember, if it doesn't have a power on it, that power is 1. So 3 plus 1 is 4. The next example, we're taking the power of a monomial. Whenever we take the power of a monomial, the first thing you're going to do is distribute that power to everything in the parentheses, each number and each variable. So negative 3 to the power of 4, x to the power of 4, y to the second to the power of 4, z to the third to the power of 4. Now, when you take the power of a power, you're going to multiply the powers. So when you have a monomial that already have a power on it, that variable that has a power on it already and you're applying another power, those two powers get multiplied by each other. Let's take a look, for example, at y to the second to the power of 4. Y to the second to the power of 4. Okay, so remember what we just did in the one before that. We took those powers and we added them together when we multiplied them. So here we have y to the second times y to the second times y to the second times y to the second. This is y to the second to the power of 4. So then we add the powers. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. 2 times 4 is 8. So whenever you have a power taken to a power, you multiply those powers. And then negative 3 to the power of 4 is 81. So when we work that out, we get 81, x to the 4th, y to the 8th, z to the 12th. X to the 4th, the x did not have a power on it, so you just apply that power of 4. Multiply 2 times 4, we get 8. 3 times 4, we get 12. And negative 3 to the power of 4 is negative 3 multiplied 4 times. Not negative 3 times 4, but negative 3 multiplied 4 times. The next example, we have a combination of both. We have 3 monomials being multiplied, but the last monomial has a power on the outside. So we need to take care of this one with the power on the outside first before we call ourselves multiplying. So we're going to bring down the first two, negative 3t to the 5th, 6t to the 6th. So distribute that power 2 to everything in that parentheses, negative 2 to the power 2, t to the second to the power 2. Negative 2 to the power 2 is 4. T to the second, we multiply, we get 4. So now we have 3 regular monomials. Now we can multiply the numbers and multiply the variables. Negative 3 times 6 times 4, we get a negative 72. And then t to the 5th times t to the 6th times t to the 4th. 5 plus 6 is 11, plus 4 is 15. Remember, when you multiply the variables, you add the powers. And then lastly, 1.06. 1.06, we're multiplying polynomials. The first example, we're multiplying a monomial times a polynomial. So here we have a monomial being multiplied by this polynomial. We're going to distribute this 4y squared to everything in the parentheses. So each one of these will be multiplied by 4y squared. So now we have 3 sets of monomials that need to be multiplied. So remember, we still use those same rules from 1.05. Multiply the numbers, add the powers on the variables. Multiply the numbers, add the powers on the variables. So we get 28 y to the 5th plus 12 y to the 4th minus 36 y to the 3rd. Now, anytime you're multiplying with polynomials, after you have multiplied everything, you want to make sure you are done, that you have no like terms that need to be combined. Remember, like terms have the same variable with the same power. Here we have y to the 5th, y to the 4th, and y to the 3rd. None of our variables have the same power. So we are done here. We have no like terms to combine. The next example, we have a binomial multiplied by a binomial. We're going to use the FOIL method, first, outer, inner, and last. So first, we're going to take the first two in both binomials, the 4x times the 5x. 4x times 5x. Then outer, the 2 on the outside, 4x times negative 7. 4x times negative 7. Inner, the 2 on the inside, positive 9 times 5x. And then last, the last 2 in both binomials, positive 9 times negative 7. Notice between each one, I just put a plus sign. The sign is going to come from when I multiply, because you need a sign there. So put a plus, and then after you have multiplied, that sign is going to come. So now multiply, and notice again, we have 4 sets of monomials. Multiply the numbers, add the powers on the variables. So we have 4x times 5x. Both of these are x to the first, so 20x squared. Do not forget that squared. A lot of students just leave that as 20x. Then 4x times negative 7, we get a negative 28x. There's only one x, so it's only one x in the monomial when you work it out. 9 times 5x, we get a positive 45x. And then 9 times negative 7, we get a negative 63. So now we have 20x squared minus 28x plus 45x minus 63. Notice that this is x squared and these are both x to the first power. You want to make sure that you do not make this an x to the first. X to the first times x to the first is x to the second, and this should be an x to the second. Now we want to find any like terms. After we've multiplied, we want to check to see if there are any like terms that need to be combined. The negative 28x and the plus 45x, they're both x to the first power. Combine them, you get a positive 17x. So 20x squared plus 17x minus 63. Now, what I was saying before about making sure this is an x squared, I noticed a lot of students, they'll make that x to the first and then add all three of those x's together. But whenever you have a regular binomial times a binomial, most of the time you get a trinomial answer. If you did not get a trinomial answer, look at your work again. There are some special cases, but 9 times out of 10, you end up with a trinomial. Now, if you are confused with FOIL, because with FOIL, let me go back, we doing first, outer. The first and outer, notice I'm taking this 4x and distributing it to both of these, the 5x minus 7. Then the inner and the last, we're taking this 9 and distributing it to the second binomial. So we can use another format, which is still the exact same thing as FOIL. It's just basically showing all of the work from FOIL. It's still FOIL. So remember, first, outer. First and outer, we're taking this 4x and distributing it to the second binomial. Inner and outer, we're taking this 9 and distributing it to the second one. So basically, if you get confused with FOIL, you can always, the first binomial, you're going to distribute both terms to the second one. So 4x times the second one, plus whatever sign is here goes here, plus 9 times the second one. And we're going to distribute here. So we get the exact same thing as FOIL. This is their first, outer, inner, and last. So when we multiply these monomials, we end up with 20x squared minus 28x plus 45x minus 63. Same thing we had when we FOILed it. The two terms in the middle are the same. 20x squared plus 17x minus 63. So I show this step to my students who get confused with foiling, because not everybody understand what foiling is. If you see it as distributive property twice, you may understand it a little better. And then the last type of multiplying polynomials, a binomial times a trinomial. We're going to do the same thing we did on that last problem where we used distributive property twice. You can still use that FOIL method where you take the x and distribute it to each one in the third one, in the second one, and then that negative 3 and distribute it to each one in the second one. That's the same thing as taking this x, distribute, then minus 3, distribute. And that's what we're doing here. So now we're going to distribute x to everything in the second one. Then we're going to take negative 3 and distribute it to everything in the second one. So now we get 2x to the third plus 5x squared minus 8x minus 6x squared minus 15x plus 24. Now that we've multiplied everything together, we want to check to see if we have any like terms. Remember, after you multiply, check for like terms. Notice we have a 5x squared and a negative 6x squared. then a negative 8, and a minus 15x. So we want to combine those two. 2x to the third doesn't have a like term, and neither does 24. So whenever you have a binomial times a trinomial, most of the time it's going to be x to the third, 2x squares, and 2x to the first, and one number. So 5x squared minus 6x squared, we get negative 1x squared, so minus x squared. Negative 8 minus 15, we get a negative 23x. So now I hope this video helped you to understand Module 1 material a little better. If not, please contact your instructor. Have a good day.